Hi, welcome back to the Gabster channel. I'm quite excited about this video because I've been waiting for this for quite some time. I've always wanted to get my own audio analyzer suite, and it's been a little bit tough because you're looking about $20, $30, $40, $50,000 for such equipment. And for what I do, what most of us do, cannot justify for such device. Still, I basically been eyeing this. This is from QuantAsylum. This is an audio analyzer, the QA403. And this guy is very capable audio analyzer for a very small fraction of the price of the big guys. So don't let the size of it fool you. And what's really good about this is the software is free. So you don't have to, again, get a company that's nickeling and diming you every month to subscribe to some either updates or to get basically the software. So basically you're going to get a fairly capable audio analyzer for around $600 versus $20,000 or $30,000. And this guy can do quite a few things like this is to test basically your audio equipment. You can test your DAC, you can test your amplifiers, preamplifiers, and things like that. It's all ready to go, all calibrated. There's not a lot of fussing around to do, so it's fairly easy to get going. To showcase our QuantAsylum here, the QA403, we're going to test a few basically products. First one is the small little class, the Amplifier by Douk Audio. This is the A05. And then we're going to test power supply. This is an imitation Studer 900. It's supposed to be a really nice power supply. We're also going to test the power supply by IanCanada. This is the LinearPi Pro. This is capable of delivering 5 amps actually, and it's supposed to be really nice also. The Studer 900 here next to it can only deliver about, say 1.5 amp, I would say 1 amp at the most. So it's more for low power devices, and if you want something for higher power, maybe the IanCanada here can deliver 5 amps. There's a whole bunch of power supplies. I just picked those two because these are some of the power supplies I really like. We also going to test the difference at my CRC, my Gabster CRC filter, and just gonna test all these and just see how good these devices are. When you first get the QuantAsylum QA403, you are going to be, you might get to be surprised that it actually just comes in a box just like this. There is no fancy power supplies, no cables, no nothing. You're just gonna get just a unit. So so you won't be able to use it right out of the box just like that. So you'll need a couple of small little things. First ones you're going to need is a bunch of little terminators. I'll put a link of those in the description below. You are going to need a good quality USB cable, and these are like the old kind of like the printer cable, because this thing uses almost like 1 amp, so it takes quite a bit of juice. So you need a fairly good cable. If you have an old printer cable, most of them are very long and have skinny wires in them, so you may find that the voltage is dropping and it might not be enough to supply it. We'll get to that in a minute. So basically you're gonna get the unit, and so you will need to get your USB cable and some of the terminators to reduce the noise by plugging in the terminals that you are not being used. Another thing you're going to need is you need to download the software. The software is free. Yeah, and this is basically the main software, how it looks. So first thing you're going to do is plug in your USB cable to basically connect your computer. And as soon as you do that, you're going to notice in the screen here on the bottom that you're going to see two things. This one says USB voltage. So basically I'm at 4.8, which is pretty good. If you start dropping below 4.6 or 4.5, it's going to give you either an orange or a red mark that you not get enough voltage. Don't be alarmed. It's usually because your USB cable is too long or has very thin wires, not adequate. So make sure you get a short one. I usually recommend like something like a 3 feet or 6 feet max, and something of a good quality cable. I'll put a link about one that I am using. And you'll see that the current is about 3/4 of an amp here. So this thing does use quite a bit of juice. So don't, some of your hubs, if you have an old computer or a port that doesn't support high current, you might want to use a USB hub, and I'll also put a link of that in the description. And the reason you might want to use a USB hub is you can also then control the quality of the power that goes into the unit and get a better quality. So you can see here it's fully isolated from the PCs, and that's what I'm talking about here. It's got differential input and output, and basically it's got a built-in attenuator. It has a 24-bit, and that's fairly important, and can handle roughly up to 40 volts. And just some, basically that gives you a rough idea. On the back you can see that you have the inputs and the outputs. And so basically it's balanced. You got plus and minus. So you got the plus and minus. You can use it as a balanced analyzer as well as single-ended if you like. To showcase our QuantAsylum here, the QA403, we're going to test a few basically products. The first one is the small little class, the Amplifier by Douk Audio. This is the A5. And then we're going to test this power supply. This is an imitation of the Tudor 900. It's supposed to be a really nice power supply. We're also going to test the power supply by IanCanada. This is the LinearPi Pro. This is capable of delivering 5 amps actually, and it's supposed to be really nice also. The Tudor 900 here next to it can only deliver about, say 1.5 amp, I would say 1 amp at the most. So it's more for low power devices, and if you want something for higher power, maybe the IanCanada here can deliver 5 amps. There's a whole bunch of power supplies. I just picked those two because these are some of the power supplies I really like. We also going to test the difference that my CRC, my Gabster CRC filter. This is the Pro version. This is version 3. And just going to test all these and just see how the QuantAsylum could help us basically understand how good these devices are. I will start testing the Douk Audio A5 first, and then I will be doing the power supplies and the CRC filter. So if you need to jump to any particular section, just feel free to jump to that and go from there. First, we're going to start with the Douk Audio here, the A5, and we are going to, this is being an amplifier, we need to actually give it a load. So I've got 2 resistors here. These are 100 watt each, they're 4 ohms, and we're going to basically load the amplifier, because you don't want to run the amplifier on empty. So here we go, I connected the load on the back. We're also going to put an input. The input's going to be coming from the QuantAsylum, from the output of the QuantAsylum to the input of the A05 here by Douk Audio. And basically we're going to be put a couple probes to measure all the measurements. We're going to have one for the left channel, coded yellow, and one for the right channel, and it's coded in red. And here you can see on the QuantAsylum, we've got the output coming from the BNC here, and I got some adapters, and these are basically coax to RCA adapters. And so these will make my life a lot simpler. And so that's going from the output here, from the, it's going to be the generator of the QuantAsylum, and that's going to go to the to the amplifier, and from the output of the amplifier they go into the input here. And we terminated the other two inputs that are not being used with 50 ohms terminator. This way to keep the noise silence, because we are using basically a single-ended amplifier, and the QuantAsylum is capable of doing balanced, but in this case we don't need the balance, so we actually terminated the other terminals. The software is free. You can download it from QuantAsylum website, and basically on the left side here you got the run, idle and stop basically, and you can decide on your sampling rate here, and this you can also decide on the attenuation in case you are using a high basically voltage on the input, and so you can attenuate that. You can decide on your display what you want to see, left, right, and frequency and input or output. And you can here on the axis you can see your dBV, X linear or X log and so forth. And you can do your FFT here and your averaging if you like. You got your windows here, and you can decide whether you want flat tops or hand. And so there's quite a few things here. The other thing is this thing has a generator, so you can actually generate a signal. So you can say, I want to generate a signal from, decide your frequency, your amplitude, and you can go from there. So for the IEMA amplifier here, what we are going to do, we are going to let's just pick 96 kilohertz sampling rate for now. It's going to be in dBV and X log, and what we're going to do, we're going to pick the frequency response. We're going to right click on it, and we're going to click 0 dB here, and basically here we're going to say OK, and then we are going to go on. If you, it's a lot of things you don't, it's hard to see at first sight, but if you right click on certain things, you're going to get dialog boxes. So if you right click on X log, you can see that you can change the frequency and the end frequency. So we're going to pick 20 to 20. And the other thing is here, if you click up here, I already have a bunch of things clicked, you can click here and you can decide what measurements you want to see on the screen. And there's a whole load of measurements. So I've got here some power watts peaks and the RMS voltage. I've got total harmonic distortion, distortion plus noise and so forth. So you could decide left channel and right channel. So I've got a whole bunch of measurements already picked up here. And but first thing we're going to do is a frequency sweep to see how the two channels are behaving. So once we have it everything, all we have to do is click run. So you can see here that the frequency response is flat as can be. Both channels are on top of each other. It's exactly the same level, and they're nice and flat from 20 to 20. Next, I'm going to show you another feature of the QA403 is you have automated tests. If you click here, you get a whole bunch of tests where you can do like so many tests. We're just going to pick one here. We're going to do let's do this one, total harmonic distortion versus input-output level. You can pick a few parameters if you want. Just going to leave it on default for now. You just press OK. And you just wait a little bit and it does everything for you. And here we go. We can see this is a test, and you can see that the harmonic distortion stays fairly low from -10 dB to +10 dB. So that's pretty good. I would like to run another test here. So we're going to do, this time we're going to do the frequency response. And we're going to change the -10 to 0 here. So just otherwise it'll do like 3 different sweeps. 1000. And instead of a logarithmic, it's going to be just a regular run the sweep. Okay, so here we go. We've got the graph. At first, you're going to look at it and say, oh, wow, what's going on? It looks crazy. But if you look more in detail, the difference here is about 0.2 of a dB. So this is like very, very small. So you need to change the graph so it just makes it a little bit more realistic. And we've got here 100K. So a couple of things. You can look here and you're going to, for example, the X maximum value, so that would be here. We're going to change that to 20,000. So that'll be from 20 to 20K. And then the what we're going to do with the Y, so the maximum value, we're going to give it 3 dB. And the minimum value, we're going to give it minus 3 dB. So now you get your graph basically in the middle, and you've got basically plus 3 dB and minus 3 dB. And so you can see that now that suddenly the frequency response is not so bad. And the difference is that from 10K to 20K, it goes up about 0.2 dB. So very, very little. If you want to make the margin smaller, you put 1 dB here and minus 1 down here. And you get basically, now you could see that the frequency response is still about probably 0.2, maybe 2.5. So it's not so bad. So it's actually fairly flat, and that's pretty normal. As I said earlier, there's so many tests you can do in the automated tests. So one day we'll do maybe just some testing on this particular amp, and we'll do a whole bunch of different tests. But at least you got a little bit of an idea, and you know how to add measurements here if you want to add things. There's a whole bunch of measurements you can add. So I hope this gives you a little glimpse on what things you can do with this QuantAsylum QA403. I have to say I'm still getting used to it, so the following tests I'll be doing, actually I did those actually first at the beginning. You know, sometimes you open something, you say, oh, I don't need to read anything or look at any other manuals or anything else. You think you know everything, but you realize that there's quite a bit of learning curve to the software to realize where things are. Things like, for example, where you see a little line under a button means you can right click on it and you get options where you can adjust. Things like that. It takes some time to get used to, but once you figure it out, it's actually a fairly easy software to use, and I really highly recommend it. I wish I had this a long time ago. For testing, I'm going to test a power supply. Basically, this is the one of those imitation of the Studer 900 that I talked about in other videos that I like because it has a fairly good output. And we're also going to test it with one of my CRC filters here. This is the latest CRC Pro. So for our test here, we have from the output, we have a BNC connector, 2 wires here. You can get those off Amazon. I'll also put a link of those as well. And this is going to go into the input. So we got the input here, so it's going to go up here. And because we're using single-ended, we're going to terminate the others, basically the negative, so we don't get any noise coming from that. So that's going to go on the input of the negative one. So basically, we're testing in a single-ended mode. And what we're going to do, we're going to take the power that's coming from the Studer 900, and we are going to power this guy in. And now basically we have power. So let's go have a look on the software and see how we can look at the quality of the setup and see how it goes. So what we're testing here is a ripple. So DC is basically shouldn't have any AC in it. So if you see some tiny AC in the output, that means there's some noise in this output. So we're trying to see how much noise in it. So the first thing you want to check is first decide on sampling rate between 48 to 192 kilohertz. And what you want to do also decide on your input attenuation. What does that mean? It depends on how many volts you're basically sending to the system. In this case, we're sending 5 volts, so somewhere around 6 or 12 might be, let's do 12 basically, might be a good idea. So we're going to tell it we're using a display, we want to see the frequency, and we're going to see the input. And because we have it plugged into the left channel, we're going to click on the left channel. It's going to be in dBV and in a linear mode here. So once we have it everything, all we have to do is click run, and we should be able to see the basically the frequency that's coming out of the input here. So this is in dBV for those of you who are kind of lost what the heck is dBV. If you are only used to, for example, RMS voltage, there is a formula between dBV and voltage. So basically, if you're kind of below 120 dBV, so you're into like basically 1 microvolt level. So if you can see here, we've got about minus 110, 120, 130, pretty much we are below minus 130 dBV. If you are wondering what is minus 130 dBV in volt RMS, we're looking about 0.3 microvolts. This is extremely, extremely low ripple. Next, I'm going to unplug my CRC filter and take it out of the way. And this time we're going to connect directly from the basically Studio 900 imitation to the QuantAsylum. So just directly, and measure again to see what kind of noise we get without my Gabster filter and see how that performs. So let's zoom in again first. So as you can see, we're getting a little bit of noise here, creeping almost to the minus 105 or so. And but because we're looking at such a long frequency and we want to see exactly what's going with this noise here, let's go basically and zoom in on it. To do that, you basically right click here on the X linear, and you're gonna see, I have it here set to start from 0 to 100 kilohertz. We're gonna go from 0 to, let's say, 20 kilohertz and see a little bit what's happening here. So now we've got a little smaller. Now you can see where the noise is. You can even zoom in even more and say, since we're gonna basically do 1 kilohertz, and see, zoom in more on this particular noisy area. So now we can see that without the filter, it's not really that noisy, but it is going up to minus 105, basically dBV. Remember, we are starting with a very good power supply here. So even the power supply on its own is still pretty good, but of course it does quite much better with the Gabster filter. If you don't want to get mesmerized too much, you can just run, say, stop, and that basically freezes the signal. And now you can basically zoom in a little bit more. So you could see basically how high it is. But again, we're not seeing anything extreme here, but definitely there is a little difference. Next thing I'm going to do, I'm just going to get one of those generic power supplies just to make you guys see a little difference what a good power supply does. And we're just going to give it a try. So I put it back from 0 to 20 kilohertz this time, and we're going to click on run, and let's have a look at the noise. So now you guys can see what's the difference between a good power supply and a bad power supply. So this guy is, as you can see, is not good. We're talking here minus 50 or 60 dBV. And let's look at actually at even a longer range, frequency range. Maybe we might even see more. Let's say 90 kilohertz here and say okay. Whoa, look at that. This is like quite the spectacle of display. Actually, it's kind of cool in some ways, but cool in a bad way, not in a good way. so you could see how this horrible power supply performs. And I'm not going to tell you, this is, you see those power supply, every time you buy a little small cheap gear, audio gear, you get those power supplies. Most of them, sadly, that's how they perform. You're getting used to the power supplies I recommend here and there, like IanCanada's linear power supply, which is excellent. We're going to test that actually in a minute, or something like the Studio 900. But once you start going back to some of the horrible power supplies, you say, oh my God, now I see what a big difference these things make. I'm interested to see what would my CRC filter would do with such a horrible power supply. Actually, let's give it a test just to humor ourselves here. Don't expect miracles, but I'll see if it makes it any better. This is actually fun. I'm doing this on the fly. I have not tried this. I'm doing it exactly. I'm learning as you guys are. So this is that same, oh sorry, where is our power supply? Here we go. So this is the same horrible power supply. So we're going to put it in my Gabster filter here. This is a CRC Pro. And we have here, we're going to plug it back into the audio analyzer by QuantAsylum. And right off the bat, let's have a look at the screen. It's actually changed dramatically from what it was before to this. What an improvement. Like, this is like a night and day change just by putting my Gabster filter. Again, like I said, don't expect miracles. There's still quite a bit of noise here at the very beginning, but definitely improved quite a bit from what it was before. Still, this is not a power supply I would use in this state, because still I would consider it noisy, especially in the lower frequency range. But the amount of drastic changes that it did for it, it's actually quite remarkable with just a small, simple device. So the QuantAsylum here, which is the main focus of our tests here, is a fairly capable device. And wait till you see my other videos. I'm going to start measuring some audio equipment. It's going to be quite interesting, because I really like it because it's just so simple. So next thing we're going to do is we're going to actually take the Gabster CRC filter out and the horrible power supply. And we're going to try actually another really good power supply. This is IanCanada LinearPi Pro. I've talked about this before, and it's actually a very nice and capable power supply. But just for the heck of it, let's just test it and see how it performs. Now, with these power supplies, you will need to use a transformer to supply the power to it, and so that's kind of, you have to work it. It's not something that comes out of the box, but if you are willing to do some DIY work, this is an excellent power supply. But let's check it out. So I've got the IanCanada Linear Pro here, and we're gonna connect it to the QuantAsylum for testing. There is no Gabster filter in between. This is just LinearPi on its own. I'm using my bench power supply here to send it about 16 volts here, just to not have to wrap around with basically transformers. So let's have a look. I've got it here connected to the QuantAsylum with a very, very short wire. So let's see how it performs. So let's have a look on the screen here. So I have not. So as you can see here, it's actually a very excellent power supply. It's mostly below the minus 130 dB, just a tiny little bit here, probably in the 60 Hertz region. We just have it just creeps in probably to minus 120. So it is as basically spec'd just slightly below 1 microvolt. And so it's a really, really good power supply. Now if I zoom in on the frequency and I just froze it, you could see that it seems here just around the 60 Hertz region. It just creeps into just minus 122 roughly. So this is pretty good. And I would say it's something you can use if you don't mind using your own power transformer to supply it. But just for the heck of it, just let's put the Gabster filter on top of it and see what happens. You can mount the Gabster filter straight on top of the IanCanada LinearPi. And as for the wiring, the power comes out from the IanCanada LinearPi to the input of the Gabster filter and then comes out from the output, and it's going into the QuantAsylum. This one is configured in CRLC mode, so basically there's a little digital filter and a resistor and a whole bunch of capacitors that can reduce the ESR. This is not just reducing ripple, but it's also about reducing the ESR to way into the micro ohm level. This is a snapshot of the frequency from 0 to 1 kilohertz, because that's where things were happening a little bit before. And as you can see right here, where we had a little bit of almost minus 120 dB, now we're down to below the minus 130 all around basically the frequency. And if we look at this into more from, let's say, up to 20 kilohertz, and we can see it's all well into the minus 130 dB, and which is basically 0.3 microvolt. And just to be sure there's nothing creeping up into the higher frequencies, I'm gonna go to 100 kilohertz here, and let's have a look now. So as you can see, yeah, nothing really creeped up all across the entire frequency. So basically, this is a really good combination of the two. Definitely, you even can use just a IanCanada linear power supply as it is. It's actually still pretty good. But if you want to reduce the ESR and just clean up a tiny bit more, then definitely the Gabster filter will help. All these measurements are being done live with the QuantAsylum QA403. We didn't have to do anything, we don't have to build anything. It's all simple, easy, just like that. You don't need any amplification to the signal. So it's really simple to use, and that's what I like about it. Another thing you can use this instrument for is to actually generate your own. Basically, this can be used as a signal generator. As you can see, you basically just adjust your frequency, and you can adjust the amplitude of the level. You can see how it's just coming lower and lower. And so you basically can use it easily as a signal generator. So it's not just for measuring. Now I've only tapped in probably 10-20% of what this instrument can do. So over time you're going to see me probably test maybe some audio amplifiers, DACs and things like that. We're going to have some fun with it and basically explore things we can do with a nice audio analyzer without spending a fortune. So if you're into and try to do some of your own experiments, this is an instrument you might want to check out. Whether you buy it or not, I don't get any incentives from the company or anything like that. I'm not actually directly affiliated with them. I just always wanted to try this one, and I reached out to them and they were gracious to send me a unit to test. I've been doing a few videos that are more geared for my Patreon subscribers. There's some really interesting topics that you may not want to miss on. If you haven't joined my Patreon yet, this is probably a very good time to join, because there are going to be some very exciting projects and discoveries that I will be posting fairly soon. So there's a link in my description below if you'd like to join my Patreon and subscribe and basically support me so I can always buy some gear and test things out. Also, there will be in the corner here a link to my Gabster CRC filters if you're interested in those, and then this corner here there will be something about my Gabster TD1 DAC. A lot of links in the description below. My speaker here if you'd like to subscribe and further support the channel. Take care, and I hope to see you again.